Today we are going to be discussing the create table statement in SQL. But before we really dive into that, I just want to preface this video a little bit. Um, Understanding how to work with SQL is really crucial, and one of the best ways to do that is to examine some of what a lot of people refer to as edge cases. Um, Basically, you can understand how a statement or an expression or some type of um, SQL code functions, and then you can understand how not to do it, right? How to break it, how to make it not work. But then beyond that, it's really important to also understand how other things, other aspects of the language, other objects and things being created can have an effect on what you're doing. So this has to do with like privileges or constraints, data types, what session or user that you're using or exist in the database. There are a lot of them. And I in no way am creating a comprehensive view or take on all of this, but instead I'm trying to cover as many different things that I can think of so that, when you encounter a scenario where you have to try to understand what would happen based on some incredibly specific information, you've already thought through that process of how does a constraint affect this? How do the correct privileges affect this, and so on. So we're going to be going over this type of content in these labs, if you will. And that's kind of my hope, is that as I provide for you a worksheet that you can follow along in this lab material, you'll be able to gain some experience in understanding how things work. Now, one of the best ways to understand what happens if you have a question is test it out. Create a scenario where the ideas that you have in your head are happening, and you'll be able to figure out what happens. Instead of getting online and Googling what happens if you use this data type and you put it here, will that be an implicit or an explicit data type conversion, or will something happen at all? The best way to test that out is try it. Jump in the code, get dirty with your coding, and really experiment with that. And that's really what's going to get you that experience. So for me, I didn't get a lot of that experience up front, and that's why it took me 3 times, I think, to pass the exam. But finally, I was able to get it. And it was because I was able to dive in the code and really understand how it worked. So anyways, like I said, this is no promise that we'll cover absolutely every scenario. But these are a lot of the scenarios that I've been able to come up with. So let's go ahead and get started. And before we jump into the code, I think it's really important to discuss privileges. Now, I'm going to be using, you can see over here, I have a couple different users here in my Oracle SQL Developer application or program on my PC. I'm going to be using lab, and I use the sys user. I've been using that in order to give privileges and manage the database. And so I used my sys user to create my lab user and give it the privileges that I need to execute all of the commands that I'm going to be using here. Now, let's start off. In order to do the create table, we need the create session privilege, we need the create table privilege, and we need the create sequence privilege. Now, I also granted myself unlimited table space. You'll need some level of table space. You can't create a table if you don't have that granted ability to use up data space on your database. And so I gave myself unlimited table space since I'm the only user. And I just use different users for different testing purposes. But there's not necessarily a need to use unlimited table space, but that's just what I've done. Now, one other thing to note about privileges. Because a table is an object that we are going to be creating, if I create that object, I don't have to have any additional privileges to insert, update, drop. Any type of object that I create, I'm allowed to manipulate in any way I would like to because it belongs to my user. It's in my schema. Now, if I was trying to use an object that was created by another user, this would be different. But we're actually not really going to get into that because you're not often going to be creating a table in another user account, and we can actually get into that more specifically in a different video. But let's get started. And we can actually really quickly, so one great thing about SQL Developer, if you haven't used Oracle's SQL Developer program, is that you don't actually have to run all of the code at once. You can actually just highlight the code that you'd like to run, and on a PC you can just select F9 and it will run. And you'll see these are the privileges that I currently have in this session with my lab user. So this is right here. This is the official syntax of the create table statement. Where did I get that? Good question. I'll actually pull it up right here. I was able to get that from one of the Oracle docs. And this goes into a couple more specifics. Oh, this wasn't the one that I was looking for. Sorry. Here we go. So this has a couple more specifics that we won't get into, but you'll see here, we've got our column definition, right? This has to do with the column name, the data type, and then we also have any table level constraints, and we'll talk about those later. We also have the as query expression, and we will be going over that at the end of this video. And then there's with no data. We're actually not going to talk about that today. And you'll see they give an example of what it could look like. And there are a lot of specific aspects to that. So let's see if we can break down, get a little bit specific. Let's start off with a simple create table statement, nothing fancy. So we'll run this, and we were able to create sample table. See, we can see that. We can look at the script output to see exactly what's happening each time we run code. And if we select all from our sample table, you'll see it shows us the two columns, and we don't have any rows because we haven't inserted any data into the table yet, but we have those two rows that I talked about, column 1, column 2. All right, let's drop this table. We're going to be dropping and re-adding this table a lot as we play around with what we can and cannot do with create table. All right, so let's start off talking about naming rules. Now, Oracle actually has a good list of naming rules here. We're actually going to start off with one that I think is slightly controversial. So you'll see here, and I will leave, by the way, I know I have all these different Oracle docs. I will leave a link with you. I'll show you where you can find those, but I will always leave these with you as well, so you can reference them yourselves. So here are some of the rules that are applied to both quoted and non-quoted identifiers, right? An identifier would be a name for an object. Now, this says names must be from 1 to 30 bytes long with these exceptions. Now, it's always been my understanding that a byte is relatively similar to one character. That might not be an exact match, but I've always found it to be that one character takes up the same space as one byte, and that may not be a perfect description, but I think it's something we can definitely go off of. Now we'll start off, and we're going to create a table called super duper really crazy long column name that definitely shouldn't be a name. I give that for a column name, but we're using it for a table name. And you can see that's 64 characters. And surprisingly enough, it lets me break that rule we found in the Oracle doc. I don't know exactly why that is, but it does. So you can see that the table was created, even though that is 64 characters. So either my assumption that one character is roughly 1 byte, or their document is not accurate. And just to preface, I'll say that I don't think that Oracle's documentation is by any means comprehensive. Sometimes it does contradict itself, and I have disagreed sometimes with it, but that doesn't necessarily mean that it's doctrine. I could be making an assumption here that's incorrect. I don't know what that is. If you happen to know the answer to this, I would love to hear it, because this kind of surprised me a little bit. Now, we can actually select from this super long table name, and we'll drop it as well. Whoops, didn't mean to right click there. And we'll notice we can actually do the same thing if we give the same name to a column. So now we have sample table with the really long table or column name. And we'll drop that table too. All right, so now let's talk about some other rules. Now, we're going to be going down some of these other rules that are listed here. And I kind of use this as a general, as like a general frame for how to go over different different aspects of the worksheet that we're going through today, the lab work. Um, so I'm taking a lot of the stuff I'm getting from this document. So um, one thing you'll notice here in this example, when we try to create this table, it's not going to work. And the reason is because we're trying to create a table called number. Now, why isn't that allowed? Well, if we actually look here, Oracle has a list of reserved words, keywords, and namespaces. And you'll see that number is listed in this reserved words list. And what those are is just obviously words. I mean, you can see like select or like exists, words that we're familiar with, right? These are just words that Oracle does not let you use when you create objects because it has other purposes for those words. And so for that reason, we can't create a table or a column with a reserved word as part of its name. Now, what we can do is we can put it in quotes. And what we'll actually do is we'll not only when we put it in quotes, but you'll see we can actually even create the name as case sensitive because it's in double quotes. So this will actually work. And you'll see here, it gets the case correct, right? Capital N, lowercase um, capital B, lowercase er, right? That's perfect. But if we refer to this table again, we have to use the double quotes. If we do this, if we don't put it in double quotes, it won't work. And it'll actually say invalid table name. And the reason is because it's a reserved word, right? That's not a valid table name. Here, if we put it in quotes, but the double quotes, but we don't continue using the correct case sensitivity, it will say the table or view doesn't exist. So that's why if you use double quotes, you have to get the case correct. So this can be kind of dangerous, and we'll talk about that in just a second. Now let's drop this table. Now, here we go again. Another rule is that a column, or a name actually for a column or a table, has to begin with an alphabetic character unless it's enclosed in double quotes like we've seen. So right here, we put the 1 before column. So this isn't going to work. But if we put it in double quotes, it lets us break the rule. And we can see that the table was created. Let's go ahead and drop this table. And we also are only allowed to use 3 special characters in the name of like a table or a column. These are an underscore, a $sign, or the pound sign. Any other special character cannot be used. And again, the name has to begin with a letter, right, an alphabetic character. So in this case, this won't work because we have an exclamation point, which is a special character that's not allowed. And it tells us invalid data type, which is really interesting. But again, if we put it in double quotes, it lets us break the rule. So a word of caution. There are a lot of these rules that Oracle has for naming, and it's important to remember these rules. And if we use those double quotes, it allows us to break these rules, which makes it very difficult to remember when we've made these different rule breakings, right? If we've changed how the case is, or we've added a character that's not typically supported, or we've put something other than an alphabetic character at the beginning of a name, suddenly we have to remember that. We have to get all of that correct, and we have to remember to put it in double quotes. Now, I'm not saying that this is impossible or that there's no scenario where it would make sense to do this, but unless absolutely necessary, I personally don't think it's a wise decision to use those double quotes just because it puts a lot of pressure on you. And even if you have the data in the database, if you can't quite remember exactly how it was, you might be referencing it incorrectly, and so you're not going to be able to create your join statements and such like that. Now, you can always come over here, and you can always look up the tables that you have over here. So it's not like you can never figure it out, but it creates more work than if you always remember that the object names always carry on with, typical Oracle naming rules. So let's go ahead and talk now about something else that's really interesting. Now you'll notice we have sample table already created. Now we tried to create another table with the same name and it says, no way, that's not allowed. Reason? Because an object in the same namespace, and we know that because they're both the same, there's the same object type, right? They're both tables. An object already has that name in the same namespace, and so we can't create a new object with that same name. We'd have to delete that, right? So we can always look here in our schema and we can see, okay, there's a table with sample table. So we can actually do this. If we put a 2 there, it'll let us create it. Boom, there we go. All right. I'm actually going to drop both of them. Okay. All right, now let's talk about data types. Now, there are a lot of different data types. We're going to be discussing char, varchar2, number, integer, blob, clob, and long. Now, I don't know if I'm necessarily pronouncing these the way that most people do, but that's just how I'm going to be going over that. The other thing is there are other data types, but I don't think personally that they're worth discussing, at least in this video. If you do want to discuss some of them, though, I'd be more than happy to talk about them in a future video. So let's start off with this very simple statement right here, right? Create table, and we have a bunch of different types of data. We'll create this table, and you'll see that we can create it, right? These are all valid. Now let's ask ourselves a question. What happens if we change some of these data types with how they're presented? Let's start off with this one. What happens if we don't specify a value? Or when I say a value, what I mean is like a parameter, right? And we can see we didn't specify a parameter, and that's okay, right? We can come in here and say that it's 2, and that will also work. But as we saw from the first statement, you don't have to. Now, what happens if we don't specify any values for varchar2? This is kind of a big one, right? We should be familiar with the fact that we need to do so. And if we don't, it'll tell us there's a mistake, right? Missing left parentheses. And what it's telling us is we got to give a parameter to varchar2. And as we can see here, the same thing with number, right? We can't specify number, right? We can specify specific parameters, but we didn't have to, right? We were able to run it before without doing that. Now let's also talk about blob, clob, and long. What if we decided to create a column, we called it column 8, and we gave it a type clob? By the way, you can see I'm using lowercase here. That's okay. These pieces are not case sensitive. Oh, I forgot to drop the table. See, sometimes you make mistakes and you got to read the description of the error and you'll know what you can do. Okay, there we go. So let us do it, right? We can have 2 different columns with the same type as clob. What about blob? The answer is, did I not drop the table again? Oh my goodness. The struggle is real, people. Okay, so we can also do that with blob, right? We can have 2 columns of the same data type. Now, what if we give column 8 the long type? This is the big one that we're looking for, right? And the answer is we can't do that. A table can only have 1 column of the data type long, and that's really important. Another thing to distinguish, for me, I had a hard time remembering what blob and clob were and how they were different from long. Long is its own thing, whereas blob and clob are both large object types. The difference is one is character, the other is binary, right? And the clob, I believe, is more for like Unicode. And blob is more for like if you're storing like a photograph because it takes it in binary, right? So long is a little bit different. We can go into that in specifics, but the important thing to take away from this, only one column in a single table can have the data type of long. So let's talk about constraints. What are the constraints we're going to talk about? Primary key, foreign key, not null, unique, and check. These are really important to understand. Let's start off with understanding what it means to create a constraint inline. So we'll have this simple create table here. And because we established that this is the primary key in the same line that we created the column, that means it's inline. There are other terms for this. I can't think of them off the top of my head. Inline may not actually be the most common term for this, but the important thing to note is that you can define primary key on the same line as when you establish the name of the column. So let's go ahead and drop that. But we can also establish it out of line, which means after we've listed out all the columns, we can add constraints. And what's beautiful about this is we can also give it a name. So we're going to do that. Perfect, right? And you'll notice right here, if we open the sample table, and if we come here to constraints, it takes a moment. I need to get a little bit more RAM for my computer. It's a little slow. But you'll see it has that pk underscore sample underscore table that we established right here. Let's drop this table, and let's actually go ahead and let's create the table inline again, the way that we did before. And we'll actually have to refresh this. And if we do, you'll see that the constraint name changed to sys underscore c, and then it gives a number. This is a system generated column or constraint name, sorry, constraint, not column. And because we did it inline, the system created a name for us. I'm going to drop that. Now let's talk about other things we can do with primary key. What if we decide to create two primary keys? Now this is different than creating a single primary key comprised of two separate columns. This is two different primary keys on the same table, each with its own column. We can't do that. We can only have one primary key. Now what happens if we try and use a clob type column as our primary key column? It's not allowed. What if we do blob? That action is also not allowed. The same thing carries over with long. And it's just because they're more complex data types, it's hard to make sure that those are all unique. So now let's look at this example. What if we create a primary key out of line that comprises of two columns, and only one of those columns is one of these unsupported data types for primary key? Clob in column 2, right? And we can see it's that second one. Is that going to be allowed? The answer is no. Not a single unsupported data type, clob, blob, and long, can be a part of a primary key in any way. Even if there are other types that also are part of it, they cannot be involved. Now, let's actually go ahead and create another table. And we're going to use this because we're going to be creating foreign keys. So we'll create this table games, and we gave the game ID column the number data type, and we're making it the primary key. Now here's just a very general statement, create table statement. And we're using foreign key out of line. We're establishing that column 2 is going to reference the game ID column of the games table we just created. And that's supported, right? So we're going to go ahead and drop this table, now that it's the sample table. And now we're going to do something a little different. We're going to try and establish this foreign key in line. And you'll notice this doesn't work, right? Now, I don't know that this is something that is like completely impossible, but I've spent a good amount of time trying to figure out how to establish a foreign key in line, again, in the same line where you establish a column name and data type, and I haven't been able to do it. So if you have been able to do so, I'd love to see your comments, but from what I've seen, this syntax right here, this does not work. So I'd love to see if you know another way to do it. But at least for here, this will not work. So let's go ahead and drop the games, this table that we're referencing, games. And now we're going to recreate it, but this time we're not going to give it a primary key. And we're going to give it 2 different columns this time. Now in this one, column 2 number of our sample table is going to reference the column 1 of our games table. And we're going to try and create a foreign key. And it's not going to work. And the answer is because column 1 is not a primary key, right? No matching unique or primary key, right? So if we drop the table games and we recreate it, but we make column 2 unique, if we run the same create table statement, you'll see it works this time, right? So we were able to drop it, create the new games table, and this time we were able to create the sample table, right? It worked. Now, what about this? Here's the deal. So column 2 references that, but what if instead we make column 1 do that? So let's drop the sample table. Let's say we wanted column 1 to reference column 2, right? The answer is this isn't going to work. And the reason is because if you'll notice, column 1 here is of type varchar2, whereas it's referencing column 2, which is of type number. These data types are incompatible. They're incompatible. So you also have to make sure that a foreign key is referencing a column that is either unique or a primary key, and it has to be a compatible data type. And you'll notice that varchar and number are not compatible. All right, so now let's talk about not null. We'll start off by creating it in line. So we'll create this table, and we can do that, right? We've established column 1, type char, not null. This is legal. And let's drop it. And let's see if we try and be a little bit redundant. Let's put not null with primary key. And if you think about primary key, it's kind of like not null and unique in the same piece. And so if we put not null with primary key, that's kind of like saying not null twice. See if it lets us do it. And it does, right? You can do that. You can be a little bit redundant with not null. Now let's see if we want to put it on 2 columns, right? We want to say the char column and the varchar2 column are both going to be not null. This is supported, right? We were able to create the table. We're going to go ahead and drop this table now. And now what if we do not null and we use a default with it, right? So let's create a sequence here. And now we're going to be using these different defaults. We're going to use default version or value of awesome. We're going to use default of sysdate. We're going to use default value, the next val of the sequence that we just created. And then this last column is not going to have a default. And it also does not have the not null constraint. So we're going to go ahead and create the table. And that's supported, right? We can create a default of just a string or characters. We can use sysdate. This is also any other date type situations are valid for default. And we can also use a value from our sequence, right? Now, one note to talk about, we use next val. You can technically also use cur val, right? The current val. However, with the sequence, it's important to note that you can only use cur val once next val has been used at least once. Because if you create a sequence and you don't use next val, there isn't actually a current value yet. You have to initiate that sequence first. And so if you've already initiated the sequence before you create this table, then using curval is absolutely supported, but using next val is always supported regardless of whether or not there is already a sequence initiated or not. So that's just something to note. Now, let's insert into this table one value, howdy, for column 4, and that's the only column that doesn't have that not null constraint. And if we select everything from the sample table, you'll see we have awesome, right? That first not null default. We have today's date, right? And then we also have that next val from our sequence that we created, right? 1, because we didn't specify anything for the sequence, it's going to start with 1 and increment by 1. All right, so let's go ahead and drop this table again, and let's test out some other things. Let's look at using a default, but we're not going to say not null, right? So we're going to say a column has a default value, but we're not going to establish that it is a not null column. Is that allowed? It seems like there's a hole in the logic there, right? Well, it's actually supported. You can do that. So you'll see here, char has a default value of a in single quotes, but this column is not null. In other words, later on you could go in and you can set a value in that column to null later on. And that's kind of the really cool, not necessarily cool, but the like special case that makes it a little bit different than if you added null to it. Because if there was the not null constraint, you couldn't later on go in and set a value to any rows within that column to null. Okay, let's go ahead and drop the table again, and let's look at creating not null as a constraint out of line when we create a table. So we create the table, got column 1, got column 2, and then we're going to create the constraint not null sample table not null column 1. And what's going to happen? It's not allowed. And the reason is because not null has to be defined in line. It has to be established on the same line when you establish the column's name and its data type. No exceptions to that rule. Now let's look at the unique constraint. Let's create a table. We'll give a column 1 the unique constraint, and we'll create column 2 as well. Standard, that works just great. We'll go ahead and drop that table now that we know that that works. And now let's go ahead and put unique in a primary key. So remember, we put not null and primary key together because that would be redundant, and it allowed us to do that. Now, unique is also similar to primary key because, again, primary key is like unique and not null put together. But this time, unlike not null, unique and primary key cannot be put on the same column. That's not supported. Not an okay action. Can we establish unique out of line? Not null, we cannot do that. But unique, we can. So not null, we cannot establish out of line, but unique, we can, right? We created the constraint's name, the constraint is unique, and we put that on column 1. That's supported. Now let's go ahead and talk about the check constraint. We'll go ahead and create a check constraint now. Just a reminder, if you don't remember what a check constraint is, because I had a hard time remembering this at first, what it means is that it checks to verify that the expression within the constraint is true before it will insert any values into the table, right? So right here, what we're saying is that if you try and insert a value into column 1, that value has to be greater than 5. And by the way, we can get into this in another video, but you can't actually create a check constraint on an already existing column if the values in that column do not meet the condition within the constraint. So if they're, for example, now, you know what, we'll get into that in another video. I don't want to get too complex, but we can do this. And it lets us do that. That's perfect. So that's the normal way to do it. Now, what if we try and do some arithmetic? What if we say not only does column 1 have to be greater than something, but what if we divide column 1 by 12 and we say that has to be greater than and equal to 5, right? What if we're trying to do some math, you know, a monthly number for column 1, and that monthly number has to be greater than 5, so we're dividing column 1 by 12. Can we do that? Yes, we can. That's absolutely allowed. Here's a special situation. What if we wanted to compare column 1 to column 2 before we inserted anything in here? Can we do that? You'll see here column 1 minus column 2 has to be greater than or equal to 5. Can we do that? The answer is this is not supported syntax. We're going to talk about in just a minute how you can actually do this. But in line, you can't. So there you go. You can do it out of line, and I'll show you an example in a moment. So what if we try and do a check constraint and we use sysdate? Nope, we can't use sysdate as part of a check constraint. And the same thing applies for using a sequence. You can't include a sequence as part of a check constraint. And those are two really important things to note, is that you can't include those things in a check constraint. And you'll see here, coming back to comparing two columns, because we're doing this out of line, we can finally compare column 1 to column 2 when we create this table as a check constraint. Boom. So now we're allowed to do that. So before it will actually create a new row, it will compare the value of column 1 and column 2, and the value in column 1 has to be greater than column 2. And again, you can only compare those if you do that out of line. Now, the create table sample, if we try and use a sequence, but we do it out of line instead, that won't work. And the same thing goes for using sysdate. The reality is sysdate and any of those other similar date functions, or I guess they're known as like pseudo columns, those cannot be used in a check constraint. Sysdate, and the same thing goes for any sequences. So just remember that if you're trying to use a check constraint, you have to get creative with exactly how you do the things you're trying to accomplish. Now the last thing we're going to talk about is create table as. Now this is a special statement that allows you to create a select statement and use its results to generate a table. So what will happen is you'll be able to create a table and fill it in with all of the results that come from a select statement that comes afterwards. So we'll start off and let's actually take a look at what's in our games table. Right, so we have column 1 and column 2. Let's go ahead and drop that. And let's recreate it with col 1, col 2. We're going to give the first one a number and the second one varchar2 data types. And now let's insert one row into the table, right? And you'll see here 1 corresponds with a number, and this definitely fits in varchar2 with a length of 100. Perfect. So now if we select everything from games, you'll see we have one row of 1, and what a great day. So now if we create a games copy table, and we say create table as, and then we use the same select all statement from games, it'll actually create a games copy table and fill it in with what we have down here. And to prove that, let's select all from games copy this new table that we just created. Boom, what a great day, and 1, just like we saw. So this is generally it. Again, I tried to look at privileges, constraints, data types, naming rules, and understanding exactly how all of those things have an effect on creating a table. I actually will be posting this video online, and you can actually access this on my website. Now, if you actually come to hive.xyz, you'll have to log in. I'm already logged in, but once you create an account, it'll actually send you to a page that looks like this. It's a dashboard page, and you don't necessarily have to fill this out. And you can come here to manage courses, and if you come here to state and select Utah, school, Western governors, subject, IT, and if you select the structured query language and click add course, it'll show up here, and then you can say that you're done adding your courses, and what'll happen is it'll bring you to your lists page where you can click on your class. And this allows you to use our search engine and whatnot and create bookmarks and folders and such. But if you click here, this will actually bring you to our forum page. And this is where we have all of the access. So I actually have this create table area, and you'll see I've already included the links that I used up here for those Oracle docs. And I'll include this video up here as well that you can watch. And I'll also include a download where you can download a worksheet to follow along with this video. So anyways, I hope you enjoyed this the content of this class, or not this class, this video. Hopefully we can create a discussion below. You can post an answer. You can type a question, or you can post any comments, concerns about this video, or if you can respond to the questions that I had for you. But hopefully this video was helpful, and I hope you feel a little bit more comfortable using the create table statement.